So before we can write equations, we need to talk about writing formulas again. Remember that your acid rules were hydroic acid comes from IDE, something ic acid came from ATE, and something OUS acid came from ITE. So on this problem, we have ic acid. Ic acid came from ATE. So oxalate was C2O4 negative 2. So, and acids all start with H. So we have a +1 and a -2. So they're going to go together, H2C2O4. You also need to know your prefixes for molecular compounds. Remember that molecular compounds start with nonmetals, and the prefixes tell us how many of each atom are present. So 1 was mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Make sure that you remember those prefixes. Pause if you need more time writing those down. You also need to know your charges. Remember that everything in that first column is a +1. Everything in the second column is a +2. Noble gases were 0. Our nonmetals were -1 for the halogens. This column through the nonmetals is a -2. Our nonmetals are -3. Carbon and silicon are both -4. Silver was a +1. Zinc and cadmium were both +2. And aluminum and gallium were both +3. We also talked about monatomic and diatomic elements. We said that most elements can be written just by themselves if it's an element. So if it says carbon, we write it as C. If it says zinc, we write it as just Zn. But there's 7 of those elements that cannot be written by themselves, and therefore they're going to be 2. Those 7 started at number 7, and they made a 7. And there were 7 of them. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. So if a problem says that you have iodine or solid iodine or iodine gas, if it says that you just have iodine, it's going to be I2. So let's practice writing formulas because we're going to be seeing that throughout the entire unit. We also talked previously that Roman numerals are the charge of our metal. So we're going to write our symbol and charge. So on your note packet, you should be writing the symbol and charge just like I'm doing here. If it ends in ATE, it is a polyatomic ion. So permanganate was MnO4 with a negative charge. So we need 3 permanganates. When I cross those charges, I get 1 nickel and 3 permanganates. Permanganate has to go in parentheses because it's a polyatomic ion. For the next example, I have prefixes. Anytime you have prefixes, you don't have to worry about charges. It says that I have 3 carbons and 7 oxygens. So C3O7. Chloric acid, it came from 8. Since it's an acid, we know it starts with H, and chlorate was ClO3 negative. A +1 and a -1 are going to cancel, just leaving HClO3. Fluorine gas. So the gas isn't mattering right now. Later we'll see that we're going to add a state symbol when they tell us what state it's in, but all we have is fluorine. Fluorine is F. So we stop and we look on the periodic table and see if fluorine is one of the diatomic elements. It is, so it's going to be F2. cadmium hydroxide. Looking on the periodic table, we know that cadmium is Cd, and we know its charge is a +2. Hydroxide, although it ends in IDE, is a polyatomic ion that you should know, OH negative. So when putting them together, although hydroxide doesn't have a number, it still has to go in parentheses with a 2. So again, I'm crossing those charges. That 1 is going over here, that 2 is going over here. And the last one here, we have sodium metal. Just like fluorine gas, the metal isn't mattering. Again, later in this video, we'll talk about state symbols and we'll say that it's a solid. But for now, all we care about is sodium. Sodium is Na. It's all by itself, so since it's all by itself, we look on the periodic table. Is it diatomic? No, so it's just Na. All right, go ahead and pause the video and do these 5 on your own. Restart when you have these 5. So ammonium was NH4 + 1, chromate CrO4 -2. So canceling out, I get that I need 2 ammoniums for 1 chromate. Lithium is a +1. Nitride is an element. Nitrogen has a -3 charge. So I need 3 lithium to cancel out a nitrogen. For this next one, the solid isn't mattering. It's going to eventually be a state symbol. Gold is Au, and it has a charge of +3. We know it's a +3 because of the Roman numerals. Chromate is CrO4 -2. So we have Au, and then we have a 2 over here, so that's going to be a 2. And then CrO4, parentheses, and then that's a 3, so a 3 there. Chlorine is Cl, but it's diatomic, so it should be Cl2. Aluminum is Al. It's not diatomic, so it's just Al. Go ahead and pause the video and do these 5. Restart when you have these 5. So hydro and ic came from IDE. So nitride is N with a -3, and it's an acid, so it starts with H. So H3N. So argon is just going to be Ar. Argon's not diatomic, so it's just Ar. Boron trichloride. We have a prefix, so it's just 1 boron because there's not a prefix in front of boron, and then 3 chlorines. Gold is Au, and that's going to be a +4. And then bromide is Br with a negative. So we've got Au, Br4. Potassium is K with a +1. Sulfate is a polyatomic ion, SO4 -2. So we get K2SO4. And then going to do these last 6, restart when you're done. So liquid oxygen is oxygen, and oxygen's diatomic, so you should have put O2. Sulfurious acid ends in OUS, so that came from ITE. So sulfite is SO3 -2, and it's an acid, so that should be H+. So we get H2SO3. Carbon dioxide, we have a prefix, so that's 1 carbon because there's not a prefix in front of carbon, and then 2 oxygens. Iron is Fe, and it says that it has a +2 charge in this case. Sulfide is an element, so it's sulfur with a -2 charge. So those cancel out, giving us FeS. Hydroic acid came from IDE. Cyanide is Cn with a negative. Acid is H+, so that's going to be HCN. And then calcium is a Ca with a +2. Silicide ends in IDE, so that tells us it's an element. And we're looking on the nonmetal side, that's just silicon with a -4 charge. The precipitate tells us that it's a solid, which we'll see in a few minutes. But for now, we don't care about that. So when we cross those, we get Ca4Si2. But remember that those reduce down, so your final answer should have been Ca2Si. So the new thing that we're learning today is chemical equations and how to write a chemical equation. A chemical equation is simply an equality between reactants and products. So first, let's label our pieces of a chemical reaction. Well, the reactants are on the left side of the arrow because they're reacting. They're reacting to produce the things on the right, which are called products. The arrow we refer to as yield. So the reactants yield the products. Yields means to produce. The little number on the bottom is subscripts. We've been using subscripts. But the two new ones, when we have a number in front, that's going to be called a coefficient. We're going to see more on coefficients tomorrow. And then state symbols are the little letters on the bottom. Those state symbols are going to tell us what state of matter we have. So S is solid. So it may say a precipitate, it may say a solid, it may say metal, it may say foil. Anything that's telling us it's a solid, we're going to put S. L is for liquid. That's going to be a true liquid, such as elements. So it's going to tell you that it's a liquid, or melted, or molten. G is for gas. And then a lot of times we're going to be having aqueous solutions. A solution is when it's dissolved in water. So for this first one, it says that you have a solution of silver nitrate. Well, we're going to ignore the word solution and write the formula for silver nitrate first. So just like before, silver is a +1, nitrate is a polyatomic ion, NO3 negative. So silver nitrate is AgNO3. After you've written a correct formula, then you're going to look and say, okay, well, it says it's a solution. A solution means AQ, aqueous. So the silver nitrate has been placed in water and it is dissolved. So our next thing is mixed with. So is mixed with is simply going to be a plus sign. A solution of potassium chloride. So potassium is K with a +1. Chloride is Cl with a negative. So that's going to be KCl. Then we look and it says it's a solution. So it's going to be AQ. Our next piece says to produce. To produce is going to be our arrow. So if it says to produce, to yield, to make, that's going to be an arrow. Potassium nitrate. Well, we know potassium is K with a +1. And we saw a second ago nitrate is NO3 with a negative. So that's KNO3. And again, it's a solution. So that's AQ. Then it says and. So and is going to be our plus sign. Silver chloride. Silver is Ag with a plus, and chloride is Cl with a negative. So AgCl. And it's a precipitate. Precipitates are going to be solids. So normally that would all be written on one line. I just ran out of room, which is why I wrote it underneath it. So that's our skeleton equation. Skeleton meaning unbalanced equation. Tomorrow we'll worry about balancing, making sure that we have equal atoms on both sides. Go ahead and try this top one on your own. Restart when you have that top one done. So chlorine is Cl, but chlorine is diatomic, so you should have put Cl2. It's a gas, so we're going to put a G. Is bubbled through a, so that's just saying that we're mixing them, a solution of iron, which is Fe plus 3, because it said plus 3. Iodide is I with a -1. So it's going to be FeI3. It's a solution, so you should have put AQ, arrow, because it says to produce. We still have iron 3, but now we have chloride with it. So that's going to be FeCl3, and it's a solution, so AQ, and iodine, but iodine's diatomic, so I2, and that's a gas. So that's your skeleton equation for the first one. Go ahead and pause the video and do that last one. Restart when you're done. Acetic acid. Ic acid came from acetate, and it's an acid, so it should have started with H. And it's a solution, so AQ is added to. Barium was a +2. Hydroxide is a -1. So BaOH2, aqueous. To produce, so arrow. Water is just H2O. And unless it tells you otherwise, water is going to be a liquid. And then barium is this, acetate is this. So then we get BaC2H3O2, 2, and it's a solution, so that's going to be aqueous.